Hey, Dr. Romano, what do you got on the board there? That looks like some organic chemistry. What's going on?
I'd like to go over with you two mechanisms, and what I want you to do is focus on the arrow movements. Let's have a look. Let's do a real simple one that everyone knows how to do. I give you the secondary halide with water and ask you for the product. What would you do? We make the chlorine leave, of course, right? Carbocation is formed. It's a secondary. Secondary would have a hydride shift to give the lower energy tertiary. And then the water would come in as the nucleophile attacks, and then we would simply deprotonate it, and we would end up with the tertiary alcohol. Everyone knows that. Let's do something a little bit more interesting. All right.
Okay, Dr.
Now,
Romano.
concept. For the DAT and the OAT exam, pretty much the only thing that's ever going to undergo a rearrangement would be a carbocation. But let's try to go a little bit deeper and see an example in where there's a rearrangement, but it doesn't involve a carbocation.
Okay.
Here's a chemical we call, this is a diketone, we call it benzyl. Don't worry about the name. And I'm going to treat this with a base, OH minus. And let's look at what happens. What I first do is I take the OH minus and do a nucleophilic attack. This hits the carbonyl carbon, and this moves out to get to here. Here's a move that you've probably never seen before. Watch the shift, even though there's no carbocation. I am going to form a double bond on the C. The group migrates over, bond moves out, and that gives me this. Now, before you have a heart attack, let's look one more time. Follow the arrows. This goes down to form a carbonyl, which is here. This moves out, which is here, and this moves out, and then we simply pick up an H to protonate, and there's my target product. So, as you can see, this is actually known as the benzylic acid rearrangement. Don't worry about the reaction, but the concept. Make sure you understand how I move those arrows and what those arrows ended up giving me as a final product. So the moral of the story is rearrangements will occur most commonly if you have a carbocation. But sometimes in base, in a situation such as this, we can also see a rearrangement, but not as common.
Okay, Dr. Romano, thank you very much. I'm hoping to get a 30 in the organic. Hopefully, if I know this, I'll be on my way.
Probably not, but good day to you. Steady that destroyer. Bye-bye.
Good day to you, sir. Wow, I'll prove to you I can get that 30. Bye-bye. Sheesh.